Okay, I think we can get started. So welcome everybody. Good morning or greetings to you wherever you are, whichever time zone you're on. My name is Lipika Ramaswamy, and this is going to be 45 minutes talking about synthetic data. Now, there are slides and all, but I don't want you to feel like this is very formal or anything. There's there's some content that I have on, but mostly I want it to be a discussion. So if there's anything you have questions about, or if you just want to chat about specific things I'm talking about, the latest and greatest, what's coming up in research, I'm more than happy to do that as well. So please let's make this as interactive as possible, and I'm very excited. So just to get started, a little bit about me. I came into the privacy world kind of by accident. So I was in grad school and I accidentally walked into a lecture theater where there was a lecture on differential privacy. And I walked in and I sat down, and it all just really resonated with me, not just, the societal impact or the long-term impacts of algorithmic privacy, or that they can have, but also that it has such a mathematical and statistical basis. Like it's just grounded in numbers or other Greek alphabets. And that was what was really exciting to me. So I just, happened to walk in there, and it changed everything for me. So for a while in grad school, I worked at Harvard's Privacy Tools Project, which creates open source libraries with differential privacy. And I was an ML researcher there, so I worked on, how do we make machine learning algorithms differentially private, and how do we do it well? And then after that, I was at Lipika, which is a differential privacy software company, and I was a data scientist there using differential privacy software. And what I realized through these experiences was I really wanted to be the person who's building the algorithms that can enable privacy preserving analysis. And that's how I ended up at Gretel, which is a startup that focuses on synthetic data. And the idea is, if you're a developer, if you're a data scientist, if you're just someone looking to share data within your organization, how do you do it well with synthetic data and other related privacy enhancing technologies? So that's a little bit about me. Gretel itself, the company is it's a very young company. We focus a lot on R&D. My team is awesome. I work with people who have interest in not just privacy, but in all fields of deep learning and ethical AI. So it's a really fun time there. But for today's session, we're going to talk about what I'm going to define as the privacy problem. We're then going to cover the what, how, and why of synthetic data. We'll then delve into a discussion on privacy versus utility, specifically focused on synthetic data. And then I'll walk you through a case study, a really cool example of some work that we did using synthetic data. Okay, so the privacy problem, right? Like, if you're a developer, you want quick access to data so that you can build, whatever pipeline you're building. If you're a data scientist, you want the same thing so that you can build a great model. You can derive great insights really quickly. But the problem that I've faced many times in my career is that access to data can take forever. The other thing is, in many use cases, like at least when I was a data scientist working on problems that require sensitive data, I didn't actually need sensitive fields many of the times, or outrightly sensitive fields. So I didn't need, a name or a social security number or even a specific birth date. All I needed was information that could help me model the problem at hand. But aside from all this, once I got access to that data, and let's say there were like many other people joining my team, and each of them needed access as well. Well, now each person has access. The data is sort of spread, however you choose to share it, maybe in its raw format, maybe with some items stripped. But the data is still out there. It's out there for people to use. It's out there, maybe someone left their laptop in a coffee shop and then it's out. So that's sort of the privacy problem. That there are some approaches to solve that are really commonly known, right? So there's the idea of tokenizing or masking, which is, well, if I have a social security number, I can just strip it from the data set, and I can go, basically say replace it all with X's, or I can replace it with a unique identifier, which has happened a lot in the past in sort of the public space, which I'll touch on in a little bit. But yeah, the idea is, right, like, oh, I don't need names. No one needs to know my name is Lipika. Just strip that out. Or call me ID1. So that's an option. Another one is to anonymize. And by anonymization here, I'll use the definition that revolves around key anonymity. So the idea is that each record needs to look like at least k-1 records. So let's say I'm the only person who lives in the 02138 zip code, but there are other people, that's in Cambridge, Massachusetts, but there are many other people who live in other zip codes of Cambridge. So maybe we aggregate up to 021 or 0213. And that sort of provides me with this kind of fuzzy privacy in that I can get lost in the crowd. But really the question there is, how do you define K? Like, is it 5? Is it 10? There are some standards that are used across industries, but what does K really tell us about the level of protection? And the idea is, well, at least my understanding is not all that much. The final approach, and I put a lot of things into here, is aggregation. So you might think of, like querying systems. You might think, okay, well, there is, for example, a data set on, I don't know, salaries, and you want to know the average salary. Maybe you don't get access to the full data set, but you do find out the average, or you find out the median, and that's giving you some statistical value. Another thing that I'm putting under aggregate is machine learning models, which, to sort of take a very simplistic view, it's many aggregates put together with a lot of fancy math and compute. So, aggregates, a lot of stuff goes in there. But the problem with all of these and other approaches that are very similar is that they're open to vulnerabilities. There's so many different attacks that anonymized data, aggregated data, redacted data is susceptible to. So one of them is linkage attacks, and that's sort of like the most common one, but I love touching on this one. There's this really famous example from 2006, so now like 15, 16 years ago, where Netflix released this data set on, I think it was movie rankings, and they anonymized the entire thing. So they had like, I think, a few 100,000 users or Netflix customers, and they got their data on movies that they liked, their movie ratings, and they put this out. It was like the Netflix movie rating challenge or something it was called. And the idea was, hey, ML people out there, people who like the model, build a good recommendation system. Except the data was just anonymized. So like the names were removed. I think some demographic information was removed, but people's ratings were still there. And there were these two privacy researchers who took this data set and were like, well, what if we just match it with IMDb records? And they were able to re-identify people based on that linkage. And so the problem really here that's highlighted by linkage attacks that have been shown to be very powerful in the past is that our data doesn't live in isolation, right? Like I might put data out on many different websites or many different platforms. Some of them may be private, some of them may be public. And if the private ones get out, well, then you can effectively consider them public if someone is able to do that type of join or matching. So that's one, is linkage attack. It's very fun to talk about. Another one is a reconstruction attack. And basically the idea here is, hey, if I have, a data set and, for example, let's say I have some sort of like querying system into it. So I can query like, give me the average age of this population, and then another population, and you get answers back. There's a study, I think, that was maybe almost 20 years old now, that basically said like, the more answers you get to questions, and if all these answers are like pretty accurate, the more easily you can just reconstruct an entire data set. So you can imagine, like, if I'm asking questions about a specific population, and then I try to change the population parameters by just a little bit. So first I ask for, what's the average age of all females? Then I ask for what's the average age of all females in this particular zip code. And I'm the only person in that zip code, then, I'd be able to figure out what my age is, like the true age. So that's the idea of a reconstruction attack. There's, of course, many more sophisticated things that are possible. if you consider even a machine learning model, for example. Another one is a membership inference attack, and that's sort of specific to a machine learning model. So if you put a machine learning model out there, there's this really common notion of overfitting in machine learning, where you train the model on certain data, but then when you go to test it, usually it doesn't do so well, and that's because these models tend to memorize their inputs, or they tend to do better on their inputs, and so like this phenomenon of overfitting is what's exploited by membership inference attacks. And the idea is like, can you take advantage of this overfitting to discover or to reconstruct examples that we use to train the model? They can get pretty fancy. And then there's a whole slew of attacks that sort of, they're very focused on machine learning. But there's this idea of memorization, which is specifically, it relates to very large parameter models or large language models. So if you think of, you're in Gmail and you're typing out an email and there's autocomplete, right? Like, okay, it knows you're saying thank you very much or thank you for your time. So those types of attacks, the way that they learn, is very prone to memorization, where they can sort of like memorize a secret that might occur in the data set. Maybe you're writing a bunch of emails and you're sending your social security number over email, and then that becomes training data to build these models that can then be used to complete your text. That's sort of a simplification, but that's a really cool attack. There's been a lot of work on it and how to prevent it. There's, of course, model inversion that's very similar to a reconstruction attack, where you're able to basically get model parameters out from the model. There's model extraction, model poisoning, a lot of different things. But the idea is machine learning models are very prone to attacks. Like there's a lot you can do, and all of these are like adversarial techniques that have been studied outside the formal privacy world, and then within the privacy world as well. So all of this is to say, I mean, hopefully I've convinced you that, like if you wanted to redact data, or if you wanted to anonymize it, if you want to aggregate it, you're still leaving yourself open to some privacy vulnerabilities. So what I'm suggesting next is synthetic data. And one way to think about synthetic data is like a jigsaw puzzle, where you replace the pieces of the jigsaw puzzle in such a way that the overall image that you're trying to make is not discernibly different. Yet at the same time, the pieces are different enough that you can't figure out how to pair a synthetic piece with the original piece that it came from. So that's a little like, it's a visual way of thinking about synthetic data. But I realize this may be a little hand-wavy, so let's talk about what this means. Basically, what we want from synthetic data is data that acts the same as our original data source, but it looks different enough that nobody's personal information is revealed. And so the goal here is to generate data, synthetic data, that can be used for a whole host of statistical tasks, like understanding underlying distributions of a population or modeling the data using machine learning methods. But at the same time, it doesn't look enough like the real data that somebody's privacy is breached. So, okay, I'm going to pause here to take a question from Carrie on overfitting. So overfitting in the context of machine learning is, if you have some examples, let's say you have a data set on COVID patients, and these patients are all located, in a specific country, they have specific characteristics, and you train a model on that, and you're trying to learn, will somebody be hospitalized or not? I know this is everyone's favorite example, but let's just go with it. And so the idea of overfitting is, if you think of a sort of classical machine learning model that learns, y is equal to mx plus b, or that type of relationship, what can happen over time as you learn more and more from the data through, something like a stochastic gradient descent or a second order optimization method, is basically you end up learning from that. You end up learning from those examples what is going on in that data set. And if there's something that's different from that data set that shows up in the future, you may not be able to generalize really well to it. So for example, you build a model on people living in the US or living in Massachusetts or living, maybe in the greater Boston area, but then you're trying to generalize to a population from Texas. And you may not be able to do that well because the model has trained really just on this one data set that might have specific characteristics that don't generalize to the rest of the population. Like it may work really well for the Boston area, but it may not work in other places. I hope that helps. The next question from Angad is, how is synthetic data different from tokenization? And we'll get to it. So let's just talk through like what is synthetic data, how we make synthetic data, sort of the questions of how, what, why, and I'll get to that. Okay, so how do we make synthetic data? It's kind of cool. These are really, really cool algorithms. I work on a lot of them. And the idea is, right, you have your sensitive data, you have records on COVID patients, you have genomic data, you have bank account transactions, so things that are really sensitive, that I would consider sensitive. And you pass them through this class of machine learning models that are really cool. They take as an input data, and they also produce as an output data. So it's data in, data out. And the idea is that the data that comes in is very similar to the data that comes out. And so these models, there are many different types of them that are used. There's, generative adversarial networks. There are ones that are based on neural networks, and then there are ones that are not. So there's generative adversarial networks, which are really cool neural nets that basically learn like what's a real data point and what's a fake data point, and they try to make better fake data points and produce good synthetic data that way. There are also language models like of the variety, that complete your sentences. And so that's also producing synthetic text, right? Because like when we're in Gmail, we didn't write that. If you just hit tab and autocomplete, the rest of what you didn't write is synthetic text that the model produced. Another type is probabilistic graphical models, and models that use sort of underlying data distributions. They try to model the underlying data distribution in its entirety and from a very like statistical perspective, and then from that distribution create realistic samples. And so the idea behind all of these models, like regardless of type, is you get some sort of data out, and this synthetic data is really like what's used for what we want to use for safe sharing. Okay, so how is it different from tokenization? Really quickly, it might be useful to think of synthetic data as not actually pertaining to any of the records in the original data. So that's sort of the way that it's different. I hope that answers the question. Is that in the synthetic data, you don't actually have any records that are from the original data. You're just learning the underlying distribution. So if your data set is showing you that there's a relationship between, I don't know, smoking and lung cancer, the data that you get out may not have the specific records, but it will maintain that relationship. Okay, I'm going to continue on just for a few slides, and then I'll stop for questions. Okay, so we have synthetic data that in theory is like safe to share, right? But how do we make it privacy preserving? So you put in some model. To recap, you put in some data into a model, you got some output. That output is synthetic data. How do you know that it's privacy preserving, or how do you make it privacy preserving? One option is heuristic. You can remove outliers from the data set. So you can say, well, the training data set, there's certain things that look like outliers and they're not really important for my problem. So from the synthetic data set, I'm going to remove that as well. The other thing you can do is look at sort of a similarity score between records that were produced from that synthetic model, and you can compare them to original records and see, well, is there anything that's just like too similar? Is there anyone who looks too similar to Lipika? Let's take that record out. There's another one. There's another method, which is differential privacy, and I know there are some questions about that in the chat. But basically, the idea of differential privacy is we'll delve into it. So the guarantee of differential privacy is that if an algorithm is private or differentially private, then changing the data input slightly doesn't change the output significantly. And so if I were to withhold my data from a data set that was being used to train a synthetic model, the output would look very similar to if I had contributed my data. And so that's the idea of differential privacy. More concretely, what we do with synthetic data or with synthetic models that are generative, that produce synthetic data, is we add differential privacy to some step in the process. So very commonly, it's added to the optimization step. There are also other methods. For example, in GANs, there are ways of making it differentially private, like private aggregation of teacher ensembles, and some notions like label differential privacy also apply, but I'm just throwing words out, and that's if this resonates with anyone. So there's a way of adding differential privacy to synthetic data. I will say that it almost always comes at a cost, in that the way differential privacy works is that you add a little bit of noise. So that little bit of noise needs to be quantified, and the way it's added needs to be proven to protect privacy. But that noise can sometimes really affect the way the model trains. Okay, I'm going to stop for some questions now. All right. Won't something like GPT-3 be able to do this very efficiently and scalably? Yeah, so something like being able to produce synthetic text. Yeah, you could do it using GPT-3. You could also use it for creating tabular data. The one thing that I would caution you about when using models like large language models that are available is that oftentimes, well, you don't know all the data that it was trained on, right? So you may not know if there's bias that exists in those data sets. Yes, there are studies on what type of data is trained on, what type of bias exists in models or in text that's generated by GPT-3. There are studies on that, but I would say really delve into that before looking at using something like GPT-3, because there's a fairness component that can become important in producing synthetic data. Okay, I hope that answers the question. Cool, thanks, Amir. Okay, how is the risk of bias managed in the ML models, especially when dealing with sensitive inputs for the synthetic data? Yeah, so often, the idea is, well, we always want to balance the bias variance trade-off. It can be a little difficult in the types of models that I work on, which are more generative in nature, but there are methods to debias based on what you want to accomplish with that. That's a possibility. There are certainly methods for it. Ultimately, I will say that with synthetic data overall, it's really important, and I think anyone who works in this space will agree that it's really, really important to define why you're trying to build the synthetic data in the first place. It's not like general purpose data, or it typically isn't general purpose data that can be used for anything and everything. So I like to think of it as, I have a specific goal in mind. Either I want to do machine learning, or I want to, maybe I want to get some sort of population level statistics, or I don't care and I'm just building some sort of pipeline to go and do my, backend software system, and I just need data that, isn't the real data, and that synthetic data works for that as well. So I think it's, at least for me, it's very important to define what the goal of the synthetic data is, and then build synthetic data for that goal. Now, of course, there are services and tools like, the kind of things that I work on right now at Gretel and across other companies and across the open source space and across academia, where people are trying to make synthetic data more and more sort of general, where you can use it for a variety of tasks. But it's always a call out. If someone says the synthetic data is good to do literally whatever you want, I would consider that. I would look at that very closely. Okay, another one is, Another question from Carrie: are there any overlaps or intersections between federated learning models and synthetic data? Yeah, they can be. So there are some models to, integrate a synthetic data model in a federated setting. I think that is possible. You do need sort of like a central curator to manage the updates, but when done with differential privacy included in the mix, there is a possibility to do it. If you just think of synthetic data models as like one class of machine learning models, yeah, in theory, it's just another model that can be done in a federated way. The complexity of it, though, is that a lot of these models are very, very finicky to train, and it can be it can be a challenge to do it even in a sort of centralized or non-federated setting. So that's the only thing it can get hard quickly. Okay. I'm going to move on really quick and then come back to some questions. All right. So we talked about the privacy side of synthetic data, right? But this entire time I've been saying, hey, I want to build synthetic data to do something specific. Like maybe I want to run a machine learning model. Let's go with that. So this is something, this is a synthetic data set that I ran a few days ago, or I created a few days ago. And what's in the purple here is the real data, and what's in the green is the synthetic data. And when I'm determining the quality of synthetic data, there's a few things that I do. There are many, many different ways to do this, many different metrics you could use. I mean, there's a lot of literature out there on judging the quality of synthetic data. A lot of it also depends on the use case. So the one specifically that I'm talking about here is for machine learning. So one way of determining the quality is to look at correlations between the training set and the synthetic set. And ideally, I want the correlations to look very similar if I'm trying to build a model that takes advantage of the relationships between different variables. Another thing is to just look at the distribution of data, right? So like, am I producing, say these are certain categories in the data, am I producing them in the synthetic data with the same frequency that exists in the training data set? So here you can see this is pretty well maintained. It didn't do too bad on the task that I needed it for. And the final thing is some dimensionality reduction. So if you're familiar with it, you take a really large dimensional data set and you can decompose it into maybe just two variables and visualize it and see what it looks like in sort of a different space. And here you can see it's not exact like one-to-one match, which is where you really have to think about like, what am I using this for? Can it still be useful? If this looked wildly different, I would see how it does on the task that I need it for, and then go back to the drawing board maybe to see if there are other things I can do to make the synthetic data better. Okay, so after that, I'll pause again for some questions. All right, Hideyuki says, my discipline is not DS or ML. When people are dealing with synthetic data and they say it's safe to share, what does that mean? It's safe to share because it's basically individuals cannot be identified? Or is there any other ground reasoning? Yeah, that's a really great question. The reason I say it's, or even I say it can be safe to share, is that it doesn't actually contain any information about, or it doesn't contain, the same records that were there in the original data set. So like, let's say, and my favorite example of hospital patients, you have that data set, obviously, like because of laws like HIPAA in the US and others elsewhere, like you can't share that data set. But if the goal was to share it with researchers who want to study a certain type of disease that's contained in my population of hospital patients, then creating a synthetic set basically says, hey, here are some individuals who could be real. I mean, they could be real. They basically represent what's going on in the real population, but it's not identifying. So one record can't be linked to me. It's just for a patient who may have the same demographics as me, maybe female, maybe South Asian, maybe under the age of 40, that type of thing. I hope that helps. Okay. I'm going to move on to some I'm going to move on to some use cases. I'll walk through it really quickly, and then we can talk through some of the questions that are coming in on use cases. Okay, so like I've said, the use case is super important when you're thinking about synthetic data and how to produce it. But it's really cool to see some of the things that you can do with synthetic data. Obviously, one big one is you train your models on synthetic data, and you can run them in production data. So your production models don't actually need to see sensitive data, and they may not be vulnerable to privacy attacks like the ones that I talked about earlier. Another one is to reduce bias in data sets. So for example, if you have like a really unbalanced data set, you could augment your data with synthetic data. And sometimes that can actually lead to performance improvements in your models. And finally, the big goal and the big hope is that you can make private data sets shareable across teams or across organizations, across research entities, and that just unlocks a lot more innovation. Okay, so one use case that I'm going to walk through really quickly, which is really cool. We have a blog on it on the Gretel website. Super cool example of this UCI heart disease data set on Kaggle, which is really popular in any data science course. And basically, what we noticed was there's an underrepresentation of females in this data set. So 32% of the population is female, which generally is not representative of the population that you might be trying to generalize to. And so the question was, can we augment this training set with synthetic records? And in a way remove this like representation bias. And I know bias is sort of an overloaded term. I am not referring to any specific definition here. I'm just saying there's a difference in class representations, and that's what we're trying to balance. So what we did, and this is sort of a notebook interface, what we did was create a synthetic model that learned the semantics of the data really quickly, and we used it to generate an additional 111 female patient data records. And we added this back to the original data set on Kaggle, and we ran through the same sort of this machine learning task. And in this specific machine learning task, basically, what we saw was the orange bar here is the results of the synthetic data. So it's the performance of the synthetic model. And you can see pretty much in all cases, or most of the cases, it's slightly higher. And what we found was that by augmenting the data set, these models actually did so much better on predicting outcomes for females. So the accuracy jumped from 84% to 90%, which was awesome. It also helped improve predictions for the male patient population from 86 to 90. So these models, or the specific machine learning models, were really helped by the addition of data that was possible by using synthetic data. Now, there are other methods of generating or augmenting a data set, like synthetic minority oversampling techniques. And those are totally valid too. This is just another way of doing it, where you're actually like learning the underlying semantics of the data and not looking at like a distance between records. Okay, I'm going to pause for some questions. I think we only have 10 minutes left. Oh, and thank you, Christine, for answering a lot of the questions in the chat. I appreciate it. Okay, I'll go from bottom up. So Jill asked, do synthetic data companies generally perform this as a service that is generating synthetic data for a customer-specific use case or as a product? There are many different ways of doing it. I think there are companies that do both. I can speak specifically to the ones that I know, and my specific product. So there's a lot out in the open source world. You can usually go find, like if you look up tabular GAN, you should be able to find plenty of implementations to do it yourself if you're so inclined. There's obviously a lot. There's a lot of complexity in training models like GAN, and so a lot of the times companies will offer this as a service. And it'll be, well, I want to produce synthetic data. I want to produce synthetic bank account transactions. I'm going to use a GAN to do that. How do you tune the GAN appropriately to build the synthetic bank account transactions? So that's one way it's done. There are definitely also products out there. A lot are open source. If you think of open source packages as products, yeah, there's a lot out there, a lot of guides on how to do this well, and how to do it with some good enough defaults. So for example, I can speak to, ways that we do it at Gretel. We have an open source SDK. So that's a Python library, and you can just go like plug into it and figure out, there are some inputs that go into it that are very specific to deep learning models. Once you figure that out, it's very much like set it and go. We do provide defaults. There are some great videos that my colleagues have done. There's also plenty of blogs that we put out there. Aside from that, we also use these open source tools. So we also use open source tools that are basically, we consider them products. And that makes it, that sort of opens the universe of algorithms that we have access to as well. So both ways, I think one is not better than the other, just depends on your expertise and your need as well. A lot of places also like productionize this, right? Like, for example, if you wanted to do the sharing within the product, that's possible in certain products. It's possible in Gretel. All right, Christine, let's talk about your question. So GAN approaches to DP synthesis of tabular data. The benchmarking study that you performed, I recall that, and I think it's related to the DP Syn challenge, isn't it? With methods that are marginal based. I do recall that. Neural nets are sort of the very exciting thing to work on and to talk about and to use. And so a lot of synthetic data methods to use that. But no, this was an awesome study. I had read the preprint. I think that was in September or something. But I'm excited to read this on like what evaluation approaches that you use as well. But yeah, like really curious to see the breadth of use cases, the applicability to different industries, etc. in this paper. But thank you for sharing this. Yeah, thanks, Chris, for sharing replica analytics as well. Yeah, there are plenty of companies that do this. If you look up like synthetic data, you can look up synthetic data open source. You can look up synthetic data in academic research. A lot of the research is actually published by companies or research groups that put out packages that can help you do this really effectively. Of course, you can reach out to me. I come from the open source world. I love open source, and that's why we build a lot of open sources at Gretel as well. So you can reach out to me if you're looking for something specific, and I can point you to things that I do know, or the platforms and companies I do know. Okay, I'm gonna just keep scrolling up. Feel free to redrop your questions into the list. Sorry, I haven't gotten to all of them. Okay, there's one from Christopher on my point of view with respect to specific classes of use cases of data outside of, let's call it native originated production purposes for collection and life, where the application of synthetic data is most applicable. Not every secondary use is an ML class of use. I think what I understand from this is, what can you use synthetic data for aside from machine learning? And also, another way I'm going to interpret this is, what are the industries, aside from things that are considered sensitive, like traditionally sensitive, where synthetic data can be used? One thing that we see, just to answer the second question first, which may not be exactly your question, I apologize, but just to go with it, because this is super exciting. One thing that we see is gaming companies use synthetic data as well, and are interested in using more synthetic data because the way that people interact with gaming systems and sort of their behaviors and habits, and how much time has elapsed between one move and the next, or so on, like things like this that can actually end up being quite identifying for a player. those are considered sensitive by, for example, gaming companies, and they want to use synthetic data to sort of eliminate the privacy problem there that they see. But aside from ML, right, there are other things, of course, that you can use synthetic data for. There is, if you refer to the DP-SYN challenge, that was, the use case there was to do a bunch of micro tabulations, I think to get marginals from a data set. There was another, there's also understanding, at a population level, what's going on. Or maybe you just really don't care about that and you need data to go into some sort of software system, and that's what it is. So you don't really need to get insights from it. You just need some data that looks and feels like the real thing, and you don't really care about correlations. And for that, synthetic data works well too. It's high lift for that type of use case, but it works well too. Please let me know if I answered that question, if I got it right, if I understood what you were trying to ask. Okay, I'm going to go up to Daniel. What is the best data steward model that works well for supporting usage of data synthesis? Is this only for a team of ML researchers to use internally? Protecting our analyst. Yeah, okay. This is a cool question. So, how do you figure out? I mean, the way that I'm reading this is, you're in a large organization, and for example, you, Daniel, have access to all this data. You want to make synthetic versions of it, or you want to have some sort of model that can, from which you can draw synthetic data sets. And how does that process work? Yeah, there are some software tools that do allow that. Like Gretel is one such software tool. That's what we call our entire service, like privacy engineering as a service, because we have this model of there are some data custodians and then there are some data users, and the interface between them can be through a product like Gretel. That is certainly one way of doing it. That does exist. That's exactly what we do at Gretel, and we've seen it works pretty well. Alternatives can be a little bit more manual. It really depends on the structure of the company. Oftentimes, it takes a lot of effort to be able to take something like Gretel into your ecosystem, or to take a similar platform into your ecosystem. So it really depends. Okay, I'm gonna hang out for another minute, and I don't know which questions I've answered and which I haven't. Sorry, not keeping very good track of it, but please drop in anything that I haven't answered yet. Oh, okay. The question from Jerome. Thanks for that. So, is there an approach to communicating error or accuracy in synthetic data? Yeah, there are some. So a lot of there are, of course, like quality metrics that exist. I think there's a lot of literature published on that, and if I recall, I think some of it is yours. I don't know. I don't know exactly, but yeah, there's a lot of literature on how to communicate, right, like quality of synthetic data or like accuracy of synthetic data. I think one way is, right, comparing distributions and whatnot. So there are all these ways of looking at whether your synthetic data lines up with the real data and how close it is, that type of thing. In terms of communicating it, yes, I absolutely think that every time a synthetic data set is produced, there should be some communication of the error metric or the accuracy metric to let someone know, hey, like I produced really good quality or really bad quality synthetic data. In fact, it's really hard. It's really hard to put these all into like a score, but we do that at Gretel. We have a synthetic quality score, and also, by the way, this is all open source, and it's also available on our platform. Like, so please go check it out. It's some composite of different things that we calculate to check accuracy, and that's one way of doing it. There is also the flip side of how private is the data, because you could have data that's like, maybe it gets a score of 99 on 100, and that's like, wow. But maybe the data does not actually qualify as private. Maybe there's just a lot of replication in the data set, and that's also equally important to communicate. I hope that answers your question, or provides some insight into how I think about this. But thanks for that. I appreciate it. Okay, I think that's all we have time for. I know we're a minute over, but thank you, everybody. I really appreciate it. Please reach out to me at my email or on LinkedIn or Medium. We also have a bunch of resources on our website at Gretel. We love building in open source, like we love building in public. So please reach out if you try some of our open source libraries, or if you try the platform. I mean, do drop in some comments. I'd love to see what you all are thinking. But yeah, feel free to reach out to me, shoot me a message. I love talking about this stuff and learning new things. So thank you very much.